You are once again welcome to this lecture room. Today we'll be looking at the topic called geometric progression. What is geometric progression? Geometric progression is a form of arrangement of terms in mathematics in which each successive terms are different by common ratio. The arrangement of terms by which every terms that you mention, when you mention those terms, the difference between the first two terms will be equal to the ratio that is going to be between the next two terms. Instead of us to be talking about common difference, like in arithmetic progression in geometric ratio, what we'll be talking about here is common ratio. Now, in arithmetic progression, we have what we normally refer to as the first term among the elements of arithmetic progression. So also we have what we call the elements of geometric progression. Elements of geometric progression are as follows. We have the A, which is called the first term. We have what we call the R, which is a common ratio. Unlike in arithmetic progression, what we have to be the differ between the successive terms is called the common difference. But here it is called the common ratio. I'm going to show you what we mean by common ratio. Now, if you have a term of this nature, 2, 4, 8, 16. If you look at each term that we have here, this particular one here succeeds this one. Why this 8 succeeds this 4? Now, if I divide this 4 by 2, 4 over 2, the term I'm going to get must be equal to when I divide this by this. That is third term divided by the second term, which is 8 over 4. 4 over 2 will give us 2. 8 over 4 will give us 2. The same thing will also happen here, which is equal to 16 over 8, which is equal to 2. We have been able to establish what we call common ratio between this set of terms that we have here. That is why we call it geometric progression. Now, in geometric progression, as I've been saying earlier, we have what we call the first term, which is represented by A. We have the common ratio, which is also represented by R. We have the number of terms, which is among the elements of geometric progression, which is number of terms. Now, in geometric progression, the first term will be A. That is the first term as it has been stated earlier. The second term will be A multiplied by a common ratio. A times R. That is the first term. Second term. While the third term will be A multiplied by R in 2 times. A times R times R. This is the third time. But the fourth term will be A multiplied by R times R times R. This is what? Fourth term. Now, if you look at this arrangement I made here very well, if I want to write it out very well, I will say this is A, the first term. Second term is AR. Third term is AR raised to power 2. And fourth term is AR raised to power of 4. Now, if you look at each of the terms that I'm mentioning, you'll discover that R is reduced in the number of R that are multiplied by one another by 1 from the number of its term. When we are in the second term, we have AR, which means that 1R does not make the second term to be the same thing as the value of its term. When we are in the third term, we have AR raised to power 2, which means 1R to be lesser compared to the number of terms that it is talking about. Also in the third term, in the fourth term, which is AR raised to power of 3, we have the R to be reduced by 1 in this number of R that are multiplied with one another as well. In other words, it means that when we have the nth term of the arithmetic progression, it can go in this way. The nth term of geometric progression geometric progression which we also have the nth term of arithmetic progression, but here we are talking about the nth term of geometric progression will be equal to Cn will be equal to ar raised to the power of n minus 1. As I have said earlier, anytime you mention the number of terms will be reduced by 1 to show the number of power that r will be raised to power. You can see there, Tn is equal to ar raised to the power of n minus 1. Now, for instance, if I ask you what is the formula, the nth term for the fourth term, which is going to be T4, that is the Tn, don't forget that is the number of terms. T4 will be equal to A multiplied by R raised to the power of what? What is it? This is the number of terms. N minus 1, that is 4 minus 1, which is going to be what? AR raised to the power of 3. That is what we call the nth term formula for the geometric progression. That is the formula we make use of to get the nth term for the geometric progression. Now, in this class, we will not only stop at defining the value or the formula to get the nth term of geometric progression. We'll also be looking at the formula method, how to get the formula of a particular given terms to us when they are in geometric progression forms. We'll be looking at how to get the formula of those terms, and we'll also be looking at how to find the terms in the geometric progression. The terms such as we can be asked to find the number of terms, we can be asked to find the common ratio, as well we can also be asked to find the first term. We can as well be asked to find a particular terms which will be also be looking at how to solve them in the next set of question we'll be looking at right away now. Also, to round this class, we'll also be looking at how to solve question that has to do with geometric mean. As we have also what we call the arithmetic mean, we'll also be looking at how we can solve a question that involves geometric mean as well. Do stay tuned. In this question we have here, we are asked to find the formula in terms of n for the given set of geometric terms. Let's look at those terms. Those terms are 15, 5, and 1 whole number 2 over 3. Now, these are the terms given to us. Obviously, we can easily see that the first term here, which is represented by A, is given to us to be 15, as we have it here. Our common ratio. Now, we can get our common ratio here by either dividing the second term by the first term or dividing the third term by the second term. Let's look at how we are going to achieve that now. 5 over 15 will give us 1 over 3. That is about that. Let's check if this value we are going to get here is going to be the same value as like this one. We also have 1 over 2 over 3. That will be 5 over 3 divided by 5, which is going to become 5 over 3 multiplied by 1 over 5. If you call this 5, we'll call this, we are having 1 over 3 as well. So it is given to us that the value of our common ratio is 1 over 3. Now, we are not going to find a formula, but you have to have it at the back of your mind. The formula for getting the value for the nth term of geometric progression. The formula for the nth term of geometric progression is given to be AR raised to the power of n minus 1. Now, we have the value of our first term, which is A, and we have the value of our common ratio, which is 1 over 3. Now, we are going to have it to be 15 multiplied by 1 over 3 raised to the power of n minus 1. Now, with this, we can now see that we have to look for a value that will be similar to the value at this denominator A. which means we must look for a value, or we must convert this 15 to a value that will be equal to this, which means 3 times a particular value. So that, I think, it will be 3 multiplied by 5. You can now say 5 multiplied by 3 multiplied by, this one will become 3 raised to the power of minus 1. You can see it, because this is the reciprocal of 3 here, into bracket of n minus 1. So this become 5 multiplied by 3 raised to the power of 1 now. This is raised to the power of 1 multiplied by 3 raised to the power of minus n plus 1. Minus 1 times n is minus n. Minus 1 times minus 1 is plus 1. So we are having now 5 Tn now. N term is equal to 5 multiplied by, since we having this value to be equal to one another, we are going to apply our multiplication rule as we have it in the laws of indices. 3 raised to the power of 1, that multiplication will turn the value at the power to positive, plus minus n plus 1. So we are having 5 multiplied by 3 raised to the power of 1 plus 1. We have to open up the bracket, minus n. We have it. 5 multiplied by 3 raised to the power of minus n plus 2. Now, we can see that this value of negative minus 1, minus n here, is added to plus to 2 here. We have to turn this negative value of this n to positive. What do we do there? Is by multiplying that particular part with minus 1. You can now have it to become n term is equal to 5 multiplied by 3 raised to the power of minus 1 into bracket of n minus 2. You can see, if I open up this bracket now, I'm going to have minus 1 times n is minus 9, which is returning the bracket. Minus 1 times minus 2, that's plus 2. So it has returned it back here. So this can now become n term is equal to 5 multiplied by 1 over 3. That is raised to the power of minus 1, raised to the power of n minus 2, which is equal to, n term is equal to 5 multiplied by 5 all over 5 now. If 5 times 1 is 5 all over 3 raised to the power of n minus 2. That is the answer to this question. That is the nth term formula for this given set of terms of geometric progression. We have another question of this nature. Stay tuned for your understanding. The question we have here is also asking us to find the formula in terms of n for the terms of geometric progression given to us here. We have the terms to be 80, 20, and 5. Clearly, our first term, which is represented by a, is given to us to be equal to 80. Then our common ratio, which is our r, will be equal to either 20 over 80, which must be equal to 5 over 20, which is equal to, when you call the two, we are going to get 1 over 4. Since we are able to get the value, which whatever the common ratio between this and this is equal to the common ratio between this and this. Since it is the same thing, it is obvious to us that the common ratio is correct. And another thing there to note there is that we are having a geometric geometric progression terms, because of the common ratio that is in between them. Now we can now go ahead to find the formula for the n term. The formula for the n term of geometric progression is given to be n is equal to ar raised to the power of n minus 1. We have the value of our a to be 80, our r to be 1 over 4. Then we will now insert it into this particular formula to get the expression proper. We are going to have it to be a is what? 80 multiplied by r 1 over 4 raised to the power of n minus 1. N term is equal to, now we'll look for a value as we have done earlier. We'll look for a value that when we multiply that value by 4, you're going to get this 80 here. So I think the value I'm going to make use of here is 5 multiplied by 16. That is 5 multiplied by 16 multiplied by 1 over 4 raised to the power of n minus 1. Now, if you look at it very well, you see that this 16 is not 4, but we can convert it to 4. What when we say 4 raised power of 2? Good, that is still it has been converted to 4. So what we are just interested in is to convert the value we have here, one of the value, to a value at the denominator here. So we have the end sum now to be equal to 5 multiplied by 4 raised power of 2 multiplied by 4 raised power of minus 1 into bracket of minus 1 and bracket over n minus 1. So we are having that one to be n sum 5 multiplied by 4 raised power of 2 multiplied by 4 raised power of minus 1 times n minus n. Minus 1 times minus 1 is plus 1. So we move ahead to have the n sum to be equal to 5 multiplied by 4 raised power of 2. You know, since it is 4, these two values are the same value, we can apply our multiplication law of indices into it. 2 plus, because of the multiplication here, you have the value at the power minus n plus 1. So we have n term to be equal to 5 multiplied by 4 raised power of 2. We open up this bracket. Plus times minus is minus n. Plus times plus is plus 1. So it becomes 5 multiplied by 4 raised power over 2 plus 1, that's what? 3. Minus n plus 3. Because of this negative value here, we have to convert this value into a positive n. So we have n sum is equal to 5 multiplied by 4 raised power of minus 1 into bracket n minus 3. If you open up this bracket here, you will discover that we are going to arrive back at this value we have initially here. So it means what we are doing is still in order. So the n term will become 5 multiplied by 1 over 4. That is the value of when you have a negative value at the power of a particular term. So raised power of n minus 3. So that will become, the final answer now is 5 all over 4. 5 times 1 is 5. You know, it's because this one is as well equal to 5 over 1. The numerator multiplied by numerator and denominator multiplied by denominator. N minus 3. So that is a formula for this n term of geometric progression given to us. Do stay tuned for the next set of questions on geometric progression. We have here, we are provided with the first term, and also we also provided with the seventh term. We are asked to find the second term. You should know what they are. So to find it, what we are missing out there is we do not have the common ratio. So let's look at how we are going to solve that. We have been given the first term to be equal to 40 whole number 1 over 2. We are also provided with the seventh term. The seventh term, now according to the nth term, the seventh term, T7 will be equal to r raised power 7 minus 1, which is equal to ar raised power 6 is equal to, we have been given that value to be equal to 1 over 18. That is the seventh term. Is equal to ar raised power 6, which is equal to 1 over 18. Now, we are asked to find the second term now. We are not given the common ratio. We can work it out. Yes. How do we go about that? Let's from this seventh term. From seventh term, which is given to be equal to ar raised power 6 is equal to 1 over 18. Then we can now say that what is the value of our a? That is going to be 2 times 80. That is going to be 81 over 2 multiplied by, what is the value of our r now? We do not have the value of our r. R is power 6 is equal to 1 over 18. That is the value here now. Now, for us to find r raised power of 6, we need to do some cross multiplication here. We can now say this value is going to become 81 r raised power 6 over 2 is equal to 1 over 18. Where we can now see 81 times 18, that will be equal to 1458. 1458 with cross multiplication. R raised power of 6 will be equal to 2 times 1 is 2. Then we can now say R raised power of 6 is equal to 2 over, we are dividing both sides by this coefficient of R raised power of 6, 1458. When we divide 2 by 1458, we are going to get R raised power of 6 is equal to 1 over 7 to 9. 1 over 7 to 9. Now, for us to find the value of RA, we have to find the sixth root of both sides. Find the sixth root of both sides. That is 6. R raised power of 6 is equal to 6, 1 over 7 to 9. This one, we cut this one. We are having R now will be equal to, what is the sixth root of 1? That is 1 over, what is the sixth root of 7 to 9? If you check it, you will get 3. So we have been able to establish the value of our R to be equal to 1 over 3. Now, we are asked to find the second term. The second term will be AR, which is going to be equal to, what is the value of our A? That is 81 over 2 multiplied by 1 over 3. 81 over 2 times 1 over 3. That will be equal to, now if you check it very well, we can call this one 2 here 1, 2 here 27. So this will be equal to 27 all over 2. That is the value of the second term. So which means that this term will be 40 whole number 1 over 2, 27 over 2, and so on and so forth like that, by multiplying the proper value of R to the terms in appropriate way. You know, when we're asked to find the third term now, that will be R raised power of 2 multiplied by the first term. So do stay tuned for another set of questions. Question we have here, we are provided with the second term and that of the sister term, and we are asked to find the value of the first term and the common ratio. Now let's look at how we can solve this kind of a question. Now don't forget that according to the nth term of geometric progression, the second term will be AR raised power AR. This is the second term. Now for the other term given to us, which is the sixth term, this is, I call this one second term, will be AR raised power of 5. Don't forget, it will be n minus 1. That is number of terms minus 1. The sixth term. Now, this is the sixth term and this is the second term. Those values that are for the n, that are the terms that are found there, have been given to us. Wow, we have the sixth term, which are given that the second term and the sixth term are given to be, the second term is 8 over 9, which is also 8 over 9, and the sixth term has given to us to be 4 whole number 1 over 2. Now, to also find the value of our first term and the common ratio, we can employ this kind of method of solving it. By doing what? Since it is common ratio we always found in geometric progression, we go about making use of division of those terms with one another. That is, AR raised power 5 over AR will be equal to, what is the value of AR raised power 5? Whatever that is the value there, you also put it there. That is what? 4 whole number 1 over 2 divided by 8 over 9. So this is going to give us, you know that A, this A we call this A. We are having r multiplied by one another in 5 times at the numerator here, and we have a single array. When this we cut off this single r, we are going to have that r to be raised power of how many r will remain there? One r has been cut off from it. It will remain 4r. That is r raised power of 4 now is equal to 4 whole number 1 over 2 will become 9 over 2. That is 4 times 2. That's 8 plus 1 divided by 8 over 9. So this one becomes r raised power of 4 will become 9 over 2 times 9 over 8. Now, after what we have been able to arrive here, we can now say that r raised power of 4 is equal to 9 times 9 is 81 over 2 times 8 is 16. For us to find the value of our r, we need to find the fourth root over both sides. Find fourth root of both sides. That is 4 r raised power of 4 is equal to fourth root here, put it here, 81 over 16. You know that this one will cancel each other out. Anytime you have a root with the same value as the power, it will cancel one another out. So becomes r is equal to, what is the fourth root of 81? What is the value that you multiply with one another to get 81? That will be equal to 3 over, what is the value you multiply with one another 4 times to get 16? That will be 2 times 2, 4 times 2, 8 times 2, 16. That is 2. We've been able to find the value of r to be equal to 3 over 2. We need to find the value of a now. Now, we are going to take any of the equation given to us to be able to get the value of a. Which one should we make use of? Let's make use of the sixth term. Using sixth term, a r raised power of 5 is equal to what is the value? Now this is 9 over 2. So we now have a r. What is the r now? That is 3 over 2. A multiplied by 3 over 2 raised power of 5 is equal to 9 over 2. We need to find the value of r raised power 3 raised power of 5 and 2 raised power of 5, which is going to be equal to 32 anyway. That's a multiplied by 3 raised power of 5. That's having a multiplied by 243 over 2 raised power of 5 will be equal to 32. Is equal to 9 over 2. Now we're going to have some. Let me put the value here. We have 243a is equal to 32. We have 243a is equal to over 32 is equal to 9 over 2. We are going to cross multiply now. We are having 243 multiplied by 2. We are having 486. 486a is equal to 9 times 32. We having give us 288. Therefore, a will be equal to 288 over 486. 288 divided by 486 give us 0.592. A is equal to 0.592. 0.592. Now, this is the value of our A. 0.592 when we make use of our calculator to solve the value of our A. Now, 288 over 48. See, you can make it to be in a fraction form by dividing it to the simplest level. That is how you get such a kind of question. We're still talking about geometric progression. Now, this class will be looking at what is meant by geometric mean. As we have arithmetic mean, we have arithmetic mean which we have been able to resolve in our first class. We also have what is called geometric mean here. Now, if we have some set of values that are consecutive values given in this form, we have the value of x, y, and z. If they are three consecutive values, that is, when they follow one another in the order without any value coming in between them, y will be their geometric mean. Now, how do we find the value of y? Now, we can now say that y over x, don't forget that in geometric progression, we always look for the value of our common ratio, which is by dividing the terms with one another. The term that is the second term by the first, the third by the second, the fourth by the third, the fifth by the fourth, and in that order like that. Y over x is equal to z over y. If you cross multiply this expression we have here, we are going to have y times y is y squared is equal to z times x. That will be what? X z. Now, for you to find the value of y, we have to say that y will be equal to y. Finding the what? By finding the square root of both sides. See? Square root of y squared is equal to square root of, when you get there, you put your positive or negative value here, xz. So therefore, this one will cancel this. We have y is equal to plus or minus root of xz. But what we always make use of here, when we have positive and negative here, is positive value. Because there is no value of n term that is negative. So we always take into note the making use of the positive value. Now, we have some questions that are going to be our question we have here is on geometric mean. Now, for us to find an answer to a question on geometric mean, we must have a consecutive terms, that is, terms that follow one another in the order of geometric. Now, let's look at those terms given to us. The first term given to us there has been given to be 1 over 1 over 2, and we have 8 over 27. This is the term given to us. But these are just two terms. For us to have a geometric mean, a term must come in between them. So let that term be, let geometric mean term be x. So we cannot have 2 times 1 plus 1, that's 3 over 2 x, and 8 over 27. Don't forget the formula we get earlier for geometric mean, where x will now be equal to plus or minus root, the multiplication of these two terms I have here, 8 over 27 multiplied by 3 over 2. 8 over 27 multiplied by 3 over 2. 2 here 1, 2 here 4. 3 here 1, 3 here 9. So we are having x is equal to plus or minus root 4 over 9. Where x will now be equal to plus or minus root. We don't have roots any longer. We can now find the root, square root. What's the square root of 4? That's 2 over, what's the square root of 9? Is 3. So now, you can now say that x is equal to 2 over 3. That is positive. Don't forget that the n value used to be positive unless you are asked to find the negative value of it as well. But the value is preferred to be positive. So the n value, the x is equal to positive 2 over 3 for these particular terms given to us here. Question we have here give us the value of 1 over 4 and 4. We are given its geometric mean to be equal to geometric mean x plus 3. So it means that this value is arranged in this form: 1 over 4, x plus 3, and 4. Now, we are asked to find a possible value of x. Now, if you put, according to the geometric mean formula, this value in the middle here is equal to x plus 3 will be equal to plus or minus of the multiplication of these two values given to us. That will be 1 over 4 multiplied by 4. So you're having x plus 3 equal to plus or minus of root 4 over 4. 4 times 1 is 4 over 4. Because this one is as well equal to 4 over 1. So this becomes x plus 3 equal to plus or minus root 1. Now, it is plus or minus of root 1. So which is going to be equal to x plus 3 will be equal to plus or minus of 1. What is square root of 1? It is 1. Now, having got the value of this one to be equal to 1, now you can now say that x will be equal to, by subtracting 3 from both sides, we are going to take this 3 away to this side becomes negative. So now we take this positive first, plus 1 minus 3, or minus 1 minus 3. So x will be equal to plus 1 minus 3 will give us minus 2 or minus 4. Minus 2 or minus 4. Now, if you look at the value we have here very well, if you put the same value in this position of x here, they are going to be suitable for this particular of x. So the value of x is minus 2 or minus 4. Let's test it now. If I put x is equal to minus 2, if x is equal to minus 2, it means that minus 2, that is x plus 3, will be equal to minus 2 plus 3, which is equal to what? Plus 1, plus 1. So it means that the value we have here is equal to plus 1. Now, so which means that this arrangement is in this form, 1 over 4, 1 and 4. So if you check it very well, let's find the common ratio now. 1 divided by 1 over 4 will be equal to 1 times 4 over 1, which is equal to what? 4. Let's check from here now. 4 divided by 1 is equal to 4. The common ratio when x is equal to minus 2 is equal to one another. So this one satisfies the value of x. Now let's also check for minus 4. For x plus 3 now, x plus 3 will be equal to minus 4 plus 3, which is equal to what? Minus 1. Now, I put this arrangement will now become 1 over 4 minus 1 and 4. So if I have minus 1 divided by 1 over 4 will become minus 1 times 4 over 1, which is equal to what? Minus 4. Then I can as well say this one divided by this, that is 4 divided by minus 1, 4 divided by minus 1 is equal to minus 4 as well. So it means that this one, since the common ratio are also equal to one another, can as well also satisfy the value of x. So it shows that the two values that we get are good value that can satisfy the value of x in these question given to us. So it has been able to find the value of x to be equal to minus 2 and minus 4. The question given to us here asks us to find the value of x and y. We have those values to be 8, x, y, and 27. We are asked to find these x and y. They are in geometric progression. They have already told us that these set of terms are geometric progression. So since this is the first term, we have a is equal to 8. We do not know the value of a common ratio, but we have another term there, which is what? This is the first, second, third, fourth. Since those terms are consecutive terms, they follow one another or in that order like that. We can now say that which term is this? This is the fourth term. 1, 2, 3, 4. That is fourth term. Tn is equal to a raised power of n minus 1. The fourth term will be equal to what? A raised power of what? 4 minus 1, which is what? AR 4 raised power of 3. And the value has been given to us here as 27. It means that AR raised power of 3 is equal to 27. From this expression here, we can be able to find the value of our common ratio. And from there, we should be able to get the value of our second term and this third term that we are asked to find it. So let's go ahead and find this. What is the value of A? 8 multiplied by r raised to the power of 3 is equal to 27. Now, this becomes 8r raised to the power of 3 is equal to 27. What do you do here is to divide both sides by 8. Divide both sides by 8. We have 8r raised to the power of 3 over 8 is equal to 27 over 8. 8 cut 8 here, we have r raised to the power of 3 is equal to 27 over 8. So now when we have expression like this in mathematics, what we need to do in order to get the value of r is to find the cube root of both sides. Find the cube root of both sides. That is the power we have on r of 3. R raised to the power of 3 is equal to cube root 27 over 8. So this one will neutralize each other. We are having r equal to, what's the cube root of 27? That's 3. Over, what's the cube root of 8 is 2. We have been able to get the value of our r to be equal to 3 over 2. Now, for us to find the value of our x is the second term. And don't forget that the second term of arithmetic progression will give us the value to be equal to AR, which is equal to AR. That is, first term multiplied by common ratio. What is the first term? 8. Therefore, x is equal to 8 multiplied by 3 over 2, which is going to be equal to 24 over 2. 8 times 3 is 24 over 2. That will be equal to 24 over 2. That will be equal to 12. Then y. Y will be equal to AR raised to the power of 2 because y is the third term. So we are having y now be equal to a is 8 multiplied by 3 over 2 squared is equal to what? 8 multiplied by 9 over 4, which is equal to 8 multiplied by 9 over 4 will be equal to, let's now try and divide it. 4 here 1, 4 here 2, 2 times 9 is 18. So I can now say that my y is equal to 18, which means that this expression has become 8, what is the x? 12, 18, and 27. Let's check the common ratio. 12 over 8 will be equal to 4 here 3, 4 here 2. 18 over 12 will be equal to, let's look at 6 now. 6 here 3, 6 here 2. 27 over 18 now. 9 here 3, 9 here 2. So the common ratio are equal to one another. It means that our workings or the solution to the problem is in order. Thanks for taking part of this class. I hope you're going to stay tuned and subscribe to our channel so that you'll be able to have access to our day-to-day value to our lecture. You'll be able to also have access to or get information from our lecture room every day. Thanks and God bless.